Hello. I wanted to talk today about common chemistry that you can see in everyday life. This will be a faster video than yesterday's, which went a little long. There's actually a lot. I mean, chemistry is the study of matter. So, just this list here of all the things you do, some are obvious. Bug sprays are obviously chemicals designed to kill bugs. Vitamins, chemicals are designed to help our body do what we want. Cooking, synthetic fabrics. We wear clothes that you can't find in nature. They can be made though, and they have certain advantages and disadvantages. When it comes to something like medicine, here's an obvious one. Aspirin. People were told by Native Americans that chewing on the bark of a willow tree would take away pain. Someone actually bothered to investigate that and discovered that there was a chemical, salicylic acid, in the bark of willow trees. It's bitter tasting, and you had to be careful what you did with it. It would make a tea out of it, but it did take away pain. They investigated further, and this scientist, Felix Hoffman from Bayer Pharmaceuticals, was able to actually synthesize it, taking salicylic acid and with a few tweaks here and there, create what we call aspirin. This was safer than the pure salicylic acid. It could be produced in large quantities, and it's a very effective painkiller. They also, while they were investigating this, accidentally figured out how to make heroin. So it didn't work out great for everyone. I think this shows an interesting thing. If there's local people who say this plant does something, it might be worth investigating. Maybe they know what they're talking about. Um, Batteries, completely different thing here. Batteries use chemicals. They're able to store energy and then use it later. That's a very useful thing, especially now that we're trying to go to electric cars. And the biggest limitation on electric cars is the battery. Whoever can figure out how to make batteries that last longer and don't take as long to charge, it's going to be very sweet and probably necessary if we're going to be able to make the transition from fossil fuels to battery powered, electricity powered cars. Now, interestingly, there's evidence that people have been using batteries way longer than you think. They found some clay jars in Egyptian pharaoh tombs that have metal parts, and it was pointed out if you poured something acidic like a wine or something into it, you would be able to generate low amounts of voltage. Now, this is very controversial. Not everyone's certain that these actually were batteries. And if they were, what were they used for? They weren't able to make a lot of electricity from it, but what exactly would the purpose be? That's interesting. And it shows you ancient people were not dumb. One discovery that's made a big difference, and it's very important, it's something we don't think of that much, is cleaning, the chemicals of cleaning. Cleaning your clothes is not just an aesthetically pleasing thing so that you don't stink. It's bad to be dirty because if you're dirty and you get cut, you'll get infected. And before we invented antibiotics, infections could be very fatal. So it's good to have clean clothes and clean skin. But a lot of the things that make us dirty, like oils, dirts, and stuff, don't always come off easily with water. So surfactants like soap, they're usually a long chain and they have two ends to the chain. One end dissolves in water and one end dissolves in oil. So if you look at this picture on the right here, you see what's happening. The soap molecules begin to they're dissolved in water, and then parts of them stick to the dirt surrounding it, and then just lift up and carry it away. Especially when you then take the clothes, you've soaked them in soapiness, and then you rinse them away. And now the water picks up these surrounded grease particles and just carries it off. And now your clothes are clean. A big discovery. Another thing that needs to be clean, water. Absolutely essential that water be clean. Otherwise, it's poisonous. Any water that hasn't been treated, other than, say, pure rainwater, there's a pretty good chance there's stuff living in it, growing in it, and those things can make you violently ill, possibly even kill you. We have a number of chemicals that will treat water, fluorine, poison, and we're trying to poison the water. We're trying to poison it to the point where it kills bacteria but doesn't kill us. You can get these little germicidal tablets, which just means germicidal means it kills germs. These are chemicals that kill germs. In large amounts, they'd be poisonous to you, but we're not going to give you large amounts. drop one pill into a gallon of pond water, shake it up. May not taste great, but there should be nothing left alive in there. And of course, we also use this for treating wastewater. The water that people flush down the toilet is the same water that's going to be coming out of a water fountain sometime in the future. Sounds nasty, but the truth is the amount of water hasn't changed on Earth. If we want to keep using it, we have to clean it. And they take that dirty, nasty water and treat it with all kinds of different chemicals with the end goal to finally have water that they can put out into a pond or reservoir, and it'll be relatively clean. And they can take it out of that reservoir, treat it some more, heavily treat it, and then send it back to you and you drink it, none the wiser. We also put, at least in most parts of the United States, fluoride in the water, another poison, in small amounts. It's not enough to make you sick. You can drink as much water out of the water fountain as you like, and the fluoride there will have no effect on you, but it is cleaning your teeth. This doesn't mean don't brush your teeth. You should brush your teeth, but just drinking the water here will help. And it's made a huge difference in the amount of cavities that we see in people based on what it was like before. Toothpaste is kind of interesting. If you look at the ingredients on the back of the toothpaste thing, they say the active ingredient thing that is really the purpose of all this is this sodium fluoride, a fluoride salt. Tiny amounts, 0.243%, but enough to really kill a lot of the germs that are in your mouth, which cause tooth decay. The inactive ingredients are just the things holding all that in there, making the toothpaste so that it can stick onto your toothbrush and taste good. There's a lot of different flavors in there. There's also something else. Some toothpaste use diatoms, which are little microscopic organisms that live in the ocean. They have a glass shell on the outside. When they die, their skeletons are basically little tiny bits of glass. So you're brushing your teeth with little tiny bits of glass. But these are, I mean, these are microscopic, super microscopic. If they were any bigger, you wouldn't want to brush your teeth with sand or something because it would scrape your teeth. That would be bad. But these are so tiny they can't harm your teeth, but they do give it a little bit of abrasion to help clean the teeth off. Whose idea that was, but it was a good one. I think the thing where chemistry in everyday life really comes into play is with cooking. Cooking is chemistry. You think about it, a chemical reaction is something that takes a substance, turns it into something else, and can't really be undone. That describes cooking pretty well. You can't uncook an egg. And a cooked egg doesn't taste like a raw egg. It doesn't have the same texture. It doesn't smell the same. It weighs different. If you could test the substances in a raw egg versus the substances in a cooked egg, they're different. That's why you can't uncook the egg. There's a lot of different kinds of chemical reactions in cooking. One of my favorites is what we call the Maillard reaction. It's the browning of food, which creates a very different flavor profile, texture. It just makes everything better. If you were to cook a hamburger, you're taking a bunch of ground beef, patting it into a patty, and sticking it in the microwave and cooking it, you'll end up with this gray piece of cooked meat, and it isn't good. It really isn't good. I don't really like microwave cooking. Microwaves are great for heating up food, but for cooking, not so much. If you were to compare that hamburger to a hamburger that was cooked on a grill, you'd be like, no comparison. It's because of the Maillard reaction. And you can see this with other things too, sometimes surprising. I'm not a big fan of broccoli and cauliflower and Brussels sprouts until I discovered a few years ago if you roast them in the oven or grill them on a grill, they are totally different. They don't taste the same. There is a really delicious sweetness that you get as it looks like they're burning. You know, it's a fine line between burning these things to a crisp and just getting that Maillard scorch on the outside that gives them a sweetness and a flavor that just is, to me, the best. You can sort of see this with marshmallows. You've had a marshmallow, just a raw, regular marshmallow. Okay, sweet, squishy. Roasted marshmallows taste way better. You know, browned on the outside. You don't want to burn it, but you want it sort of browned on the outside and gooey in the center. And a lot of this is that sugars and proteins, when they react with heat, form something new. It has a brown color and it just tastes better. Caramelization is an example of this. And any kind of meat, even if you're making stews, I would tell you take the meat before you dump it into the stew and brown it, get it scorching, sear it on the outside. It's just so much better that way. If you're making chili, if you're making ground beef for a recipe, hamburger helper, or making chili or something, here's a good tip. Cook it out, cook it on your stove top. Keep pouring out the juices. Get rid of them because otherwise you're just boiling your meat. Boiled meat doesn't scorch, it doesn't get browned on the outside. You got to pay attention while you're doing this. So you don't want to burn it, but you do want to get it crispy on the outside. It just tastes so much better. People are like, oh, your chili is fantastic. What's your secret? Don't tell. A lot of it is pouring off those juices as you're cooking so that you're actually browning the outside of the meat, not just boiling it. And another example of this, I love this stuff. Again, I'm not a huge onion fan, but I love caramelized onions. Caramelized onions is you cut the onions up, you coat them in oil, put them on a cast iron pan or something, start cooking. Got to figure out the right temperature and everything. It's going to take about 20 minutes or so. And they go from looking just like onions to brown onions to what look like you overdid it. You burn the onions and you're about to throw them out. Before you do that, try a few. And what you think is going to be a crispy, nasty, burned onion is actually a sweet, delicious onion. It takes a little bit of practice to figure out how to do this, but once you do, boy, you pop a few of those into almost anything. Toss them into a soup, toss them into whatever, put them on sandwiches. They're the best. Caramelized onions are fantastic. It's amazing though, you'll see a giant onion turn into just a little tiny handful of caramelized onion. But definitely worth it. That's a secret ingredient that'll make your cooking really pop. Sometimes we use acids not just to make things taste sour, because we remember acids have a sour flavor, but also for their chemical properties. If you slice an avocado or an apple and let them sit out in the air, the oxygen in the air starts reacting. It causes an oxidation reaction. And the result is the flesh of the apple and the avocado start changing colors. They start browning and getting soft, and people look at that and it's not very appetizing. It looks like it's old and kind of nasty. You can stop this reaction by taking some lemon juice and brushing it off because now the dropping the acidity of the outside reduces the ability for that reaction to occur. So you're using chemistry to fight chemistry and keep it looking nice. Here's an example of some chemistry that really served humans well. Cheese. Milk has been a very useful protein, an effective one. Um, Good for people, contains fats, proteins. Unless you're intolerant to it, it's a very good food, but it spoils real fast. Especially back in the day when there were no refrigerators. You got the milk out of the cow or goat or whatever. It's warm. It's not going to last long. They would try to store it in containers. One container they used was stomachs of like sheep. And they discovered when they did this that a lot of times the milk would go bad, but go bad in a way that was kind of good. It got thick and gooey and had an interesting flavor to it. They had accidentally discovered cheese. It turns out the inside of sheep stomachs have chemicals that will do that to milk and allow some of the bacteria and funguses that are always floating around to infect the milk and turn it into a new product. This was groundbreaking, especially when they figured out that they could use this to make milk products that could last for a while and have completely different flavors. If they took this stuff, this soft curdled milk, and put it in some caves, it would turn into blue cheese from the funguses that lived in that cave at that temperature. In other places, they could infect it with something that would produce gases and make bubbles in the cheese, and that's how they got Swiss cheese. Hard cheeses actually last for weeks or even months, again, without refrigerators, because they didn't have refrigerators back then. Uh, in the wintertime, when you can't grow food, you have to have stuff that you can store. And here's a way you could store food. And so a big advantage. There was another thing that they discovered, another kind of chemistry, and that was fermenting. There's different ways of doing that with different results. Sometimes you end up with alcohol, sometimes you end up with sweet flavors or sour flavors. But all of them had one thing in common: fermented food would last longer than just regular food. Sauerkraut, kimchi, they would take cabbages and spices, throw some salt in there, put them in a clay jar, seal it up, bury it in the ground. And then in the wintertime, when nothing's growing and you're getting hungry, go dig up that jar. Stuff hasn't gone bad. It started getting infected. And bacteria broke down the food, made it soft, made it sour, but then they so poisoned their environment that they died. And now the food is pretty sterile. There may be still some bacteria living in there, but they tend to be good bacteria. That's the trick to fermenting food, is to try to get good bacteria, not bad. These are not my favorite kinds of food, but I'm trying to incorporate some more of them into my diet because a lot of the natural microorganisms that live in fermented foods seem to help our own gut biome. We have living things living inside us. You may have noticed when you take antibiotics that you get sick to your stomach because you're killing not just the bad bacteria, but the good bacteria as well. And eating things like this can help. So if you're taking antibiotics, it might not be a bad idea afterwards to eat some yogurt, eat some, what they call probiotics, kind of get things back into your intestine and get things back to normal. One last bit: difference between, say, dissolving and melting. Dissolving is you break them into little tiny pieces and dissolve them in water. Take sugar, you put it in water, stir the water. The sugar is still sugar, the water is still water. Nothing has really changed. If you melt sugar, it starts changing color. It's turning into caramel. It doesn't have the same chemical properties that sugar had. And when you let it cool down at first, it turns into like a soft syrup. If you keep on heating it, it changes further. And now when you melt it down, when you let it cool, it turns into something you can break, hard crystals. Caramel has a different flavor profile than pure sugar does. It's weird. If you melt sugar and spin it, you get cotton candy, which has its own very unique flavor profile. There's just so much out there. I recommend everybody take a cooking course, or at least read a few books on the science behind cooking. Figure out why did I cook something and it didn't work. Cooking is basically science. It's chemistry. They give you ingredients, you use the ingredients. Do not substitute the ingredients. There's usually a reason why they tell you to use this instead of this. And if they say use kosher salt, use kosher salt. Do not use regular salt. There's a reason they said use the other. Make sure you have the right measurements, not a pinch, not a handful, a spoonful, a tablespoon, teaspoon, whatever. Follow the instructions. That's a good idea, whether you're doing a chemistry lab or cooking a meal. Time it right, pay attention to what you're doing, and the results will be success, whether we're talking about organic chemistry lab or just impressing that date of yours with your cooking prowess. It's, I think, really an important thing that every human should know how to do their laundry and cook their own meals. It's nice if you end up with someone who can do that with you, but if not, it's a good skill to have. So, anyway, here's what I want you to do: find something in your house, find some food process for some food item. Look at the ingredients. They, by law, they have to list the ingredients all over the place, and find a chemical that you're not familiar with. I don't want you to do water. We all know what water is, or something that just says natural flavorings. Find some chemical with a weird name and submit that. Look it up, find out what it is, how it's made, what's it for, why is it in there. They're not going to put anything in there they don't think they need. You'll find that a lot of them are preservatives to try to keep the food from going bad. So you don't, when you buy it that day, it might be weeks before you get to use it. This will help preserve it. If there's any evidence of reasons why we should probably avoid it, put that in there too. Keep in mind, a lot of people would say, "Oh, I only want food that's all natural." I mean, isn't everything natural? It's not supernatural. They're not putting ghostly stuff into your food. It may not be something that is normally found in that food, but there could be a good reason for that. Just because something's natural doesn't mean it's particularly good for you. Um, Nature has been killing us for a long time. A lot of food goes bad if you don't put preservatives into it. And that would definitely be bad. You've ever eaten, if you've ever gone to a fast food place and gotten some chicken that was maybe sitting out just a little bit longer than it should have been, and you feel the effects of that, food poisoning is no joke. But give that a shot. Let me see what you got. And I will see you one more time tomorrow.